So let's continue. In Comcast, we are running many Cloud Foundry instances across many sites, and that's why Geo-Distribution of Ingress is important. So just a little bit about myself. I was born and raised in Russia. I am a father of two and grandfather of two now. I love to travel, sail, play music, run on a spare time that I don't have. I'm a distinguished engineer at Comcast. Comcast used to be known as a cable company, but not anymore. We have a lot of different services provided to customers, to businesses. And the way how we do it is through software. So from where I stand, Comcast is a software company. And I see my role as a helping developers, so my product is a developer experience. And I'm Snap, that pronounced like Snap, that's how we call our platform, Cloud Native Application Platforms. That includes Cloud Foundry and other variations. So I'm very proud to be one of the first who brought Cloud Foundry to Comcast. That was back in 2014, 10 years ago now. We are growing since that. So we are spreading our Cloud Foundry instances across availability zones, across regions, across different clouds and cloud providers, and across continents. And when we are doing this, one of the problem we have is how we distribute everything. How we distribute actual applications, how we distribute data. But today I want to focus on the distribution of the ingress. I'm sure most of you had that experience when Cloud Foundry brought first time in the organization, introduced to the developers, and they do CF push. And a few minutes later, the application is ready and ready to consume. As I mentioned, we have so many different services that are important, critical for businesses, for families. So we definitely cannot just put our critical application in a single Cloud Foundry instance. We have many eggs, we need many baskets. So that's why we run multiple Cloud Foundry foundations. And that's what we start to do from the very beginning. We just deploy multiple foundations in different places, and developers do CF push, CF push, CF push. Application is running in the multiple locations. But next step is how the distributed application now make available to customers. It was not a problem for Comcast because way before Cloud Foundry, we had a networking team that provided application load balancer for everybody. So it's just a matter of developers, after doing three times CF push, to put a ticket to the network operations, describe what kind of health checks they're going to do, what are IP addresses of HA proxies, and so on. And a couple of weeks later, they have the application is production ready. So now we saw dynamic, which is very different from minutes from code to deployed application, and then a couple of weeks to actually have it available to the end users. So we decided to iterate and improve. And the way how we did, we paired with the network engineering team and fully automated, fully codified that provisioning process. And we did it through Service Broker API, which is the API behind Cloud Foundry Marketplace. So now any developer can do the configuration of load balancers and GSLB devices, global service load balancers, just with the CF create service, CF bind service commands. So what is the end result? The end result is in 15 minutes, DevOps team can move the application from source code to fully production ready to be consumable by customers. And that was a huge success. It really released a lot of operational activities, a lot of time from DevOps teams and also from network operations teams. So they can invest this time in actually putting new services for our customers. So reduce operations, put dev on top of DevOps, not operations. I have more time to finish my talk, so I'll start to talk about what are the next steps. Right? So the model that I described works. Actually, it's an industry standard, so it works across many companies, many organizations. Yet we want some improvements. So we want to iterate on that success and see what can be done better. There are a couple areas where we wanted improvement. One area is the developer experience. Defining health checks and all the details about IP addresses. Developers are humans, and some of us have fat fingers. So we make mistakes, and when mistakes are made in like a health checks or IP addresses, it's very hard to troubleshoot. There is a limited visibility. It takes time to resolve this kind of problems. So we want to completely remove this burden from the developer so it will be easier, not just self-service, but easier self-service to provision the application. But another side, outside of developer experience, is a customer experience. GSLB, global traffic management, usually implemented with a DNS. And DNS, when you type www.xfinity.com, then it is going to DNS server. And if it is a smart DNS server, if it is GSLB, that DNS server actually has a pool of IP addresses to pick up and return some to the requester. And from that pool of IP addresses, GSLB device also do health checks to all of those IPs to identify which application is healthy where. This is periodic, so when there is a request, give me IP address for www.xfinity.com, the smart DNS, this GSLB, returns a couple of IP addresses that it knows they're live, they're working. Actually, it knows that they were live and working during the last health check, right? That might be 15 seconds ago. Maybe it's not live and working anymore. But also the whole DNS propagation might take some time and may be cached in multiple places. So the actual failover is not guaranteed. Failover might take some time, might take seconds or minutes. So what it means? It means even if we are running fully distributed application, there is always possibility for micro outages. They're micros, they're not affecting all the customers, but they might affect a small number of customers for a short period of time. Yet, we want to improve that. So we came up with this idea that DNS is a not good way to manage traffic. We want to manage traffic and direct traffic actively, not passively. So we actually want to have a routing tier, a set of proxies that will be able to direct traffic, not just to local Cloud Foundry foundation, but across regions as needed, based on to provide the best outcome from resilience perspective, latency, availability, everything else. So essentially eliminate DNS from making any decisions about how traffic is going. Cloud Foundry has Go routers, and as mentioned before the launch, so also many companies running HA proxies, and we do as well. But those Go routers have a view of application instances in local clusters. They don't know what is running, which applications are running on the other side, on the other state, or in the other data center. So we decided to create this layer, essentially elevate the functionality of Go routers to be global, and we call it Global Ingress. We had that implementation for 2 different platforms, right? So when I mentioned Snap, it's not just Cloud Foundry, it's also Kubernetes. So we have implemented this model for Kubernetes and for Cloud Foundry. And I'm going to dig deeper into more technical details how we did it. And I'll start with Kubernetes. So what we need for this is essentially a set of proxy servers that has a discovery mechanism to be able to discover workload across multiple sites. And what is better for this than a service mesh? Right, so we decided to use Istio. Istio is super powerful and flexible and can be configured not just as a service mesh, but can be configured as a powerful mesh across multiple locations and multiple Kubernetes clusters. So this middle part is in the blue is a Global Ingress. So it is essentially a set of Kubernetes clusters located in different places, and each of them is running Istio Ingress and has a discovery. They're not running discovery for each other. They're running discovery against workload that is running on multiple independent Kubernetes clusters dedicated for the workload. But while they're doing this discovery, each of these Global Ingress cluster is fully aware about workload, not just in its own local location, but across the whole footprint. And because they have this knowledge, we can provide policies to define how we want to shape traffic. So again, from a technology here, it is Istio, but configured and built in a way to implement our idea of a separating ingress layer from the workload and make both of them independently distributed and independently scaled. As I said, my primary focus is a developer experience, right? So how would the developer experience looks like to work on this kind of platform? Well, we are not providing developers access to 20 Kubernetes clusters to do all the commands to configure Istio. That would be against good DevX practices. So we have created a set of controllers and custom resources that are very highly opinionated, high level, with only information that makes sense for developers. They don't know which data center this is running. They don't know what Istio is. Some of them do, some of them don't. They don't care, right? So they just put the application, here's my source code, run it for me. And we have it running in production, this model, for more than a couple of years already. It really proves it works. It's a good model. It brings resiliency on the next level. It also brings user experience, developer experience on the next level. What I mean by this is the developer is not longer doing CF push, CF push, CF push 3 times and then configure something on top. So the application is pushed as a single unit, and the platform is doing all this distribution. All right, so that's Kubernetes. But what about Cloud Foundry? So for Cloud Foundry, we decided that we want to reuse the same well-working Global Ingress EST layer. EST runs proxies. You can put all kinds of policies and configuration. Works great for us. But obviously, discovery mechanism is different. So there is no like a native EST discovery that can be run on Cloud Foundry, at least not I'm aware of. If anybody tell me, please. So what we have created is a service mesh feeder or global ingress feeder that is on the left. So that feeder is connected to Cloud Foundry foundations, and each foundation runs its own feeder to feed to every single Global Ingress cluster. Cloud Foundry is a complex system, and there is one very good piece in Cloud Foundry that has a lot of events about everything that is happening is NATS. So NATS is a service, is a message bus that is used in Cloud Foundry, and every events about routing changes or application instances start and stop are going through NATS. So we attached feeder to the message bus, and every time when we see event that is related to the routing, we immediately update topology on the global ingress layer. So no health checks, all the propagation is immediate. So that is the discovery piece, and also the user experience piece. So we still implement it with a service broker. So we have another service broker that helps to developers to introduce new applications to the global ingress, and service broker is doing configuration that is needed in the global ingress. So again, the end user, the developer experience is very familiar. It's the same CF push commands and CF create service, CF bind service. Full disclosure, we are not running this in production. So we implemented two levels of POC, two iterations. That is showing that yes, it can be done. It works very well. It provides immediate failover. There are no micro outages anymore. We're still trying to work and think how it can be scaled to the scale that we have.
Questions now or at the end?
Oh, questions. Let's do questions now.
Your diagram, how often would an app exist across foundations versus just using the ingress as a routing layer? How many of the apps are multi-foundation versus just using the routing layer as a selector of foundations? Does that make sense?
How many apps on foundation
Are multi-foundation, so...
are multi-foundation? Okay. Good question. So all of them. So everything that is in production is a multi-foundation. We don't put our eggs in a single basket. That's the rule. Obviously, development and all kind of experimentations, no problem with that. But production, multi-foundation, everything. So, any other questions? So I just want to summarize. while the previous iteration worked very well for us, we're still trying to improve. And global distribution is a very important part that needs improvement. So this ingress eliminates micro outages. Convergence is immediate. There is no health checks. There is no DNS cache somewhere. And proxies like proxies used by ISTIA can do even retries. So even at the moment when a request is made, there is some problem with one specific application instances, it can retry. So we completely eliminate any kind of disruptions, any kind of outages. At the same time, we optimize traffic for low latency. So that means that the customers, Comcast customers, has best minimal latency that is possible with no outages, even no micro outages. And definitely for developers, for DevOps teams, the benefits are much simpler managing the applications as a single unit and much simpler distribution. But again, some of this is implemented, some of this is not. And my main reason why I'm here is how we can work together and keep improving Cloud Foundry, not just individual foundations, but how we can build farms of Cloud Foundries and connect them together from all perspectives. Right? And Ingress is just one of them. Another is how we do safe deployment and distribution of applications across multiple Cloud Foundry foundations. How we deal with data and managed services that are still managed service broker API is still very foundation specific. It's pretty hard to make it to create and manage services in a distributed way. So that's pretty much call for action. If anybody wants to talk about this, please do. We are always open to work together, and if we can contribute and work together on this, I'll be very happy to hear about that. And finally, the shameless plug, Comcast is hiring. Careers.comcast.com has open positions. And if you're not using Comcast yet, please try xfinity.com.